One of the great things about writing an interactive program is that you can make it interactive. You can respond to the things that your users do. Users can use any of thousands of pieces of hardware that you can connect to a computer, but of course the most common ones right now are the keyboard and the mouse. So let's look at how we respond to the keyboard in a processing program. Processing offers a bunch of tools for talking to the keyboard because there are sometimes some subtleties. Most of the time, we don't care about the subtleties. We just want to know, did someone hit the space bar? Did they hit the H? Did they hit the Q key? And for those kinds of purposes, things are very simple. Processing gives us two procedures and one variable. The first procedure is called keytyped. It's of type void, so it doesn't return anything, and it doesn't take any arguments. If you have a function called keytyped in your program, processing will call it every time a key goes down. If you have a function called keyReleased in your program, processing will call it every time a key comes up. And so that you know which key went down or came up, there's a global variable. It's a character and its name is key. Unlike my own convention for global variables where I always start them with a capital letter, and I suggest you do the same, processing's own globals don't do that. They start with lowercase letters. So this variable, key, is a character, and it holds the key that just went down or just came up. We'll look at all of these in detail in just a moment. Let me give you an idea for how this all works over time so that you have a picture for what's happening as your program runs. Suppose that this arrow represents the flow of time from the left to the right. So the program starts at the far left end of the arrow. We know that draw gets called 60 times a second, so we can think of an alarm clock that goes off every 60th of a second. The first time the alarm clock rings is at the very beginning of the program. So the alarm clock rings, processing says, hey, I need to call draw, and maybe it draws a red box and a gray background. Then processing is off duty, and it says, I don't have anything to do for a while. I will relinquish control of the computer to let the machine manage your MP3 player, and maybe you're reading mail and you're scrolling in your web browser and you can do other things until the alarm clock rings again. Oh my gosh, 60th of a second has passed, time to call draw again. We draw another picture, and then we're done. We go off duty, we let the computer do other things until the alarm clock rings, processing calls draw, and this keeps going. Every time the alarm clock rings, processing calls draw and draws a picture. And then it goes to sleep until the alarm clock rings again. In practice, draw usually takes far less time than I'm showing here. It takes like almost no time at all, and the computer spends most of its time doing other stuff for you. But let's suppose draw takes a long time and that this is representational. Somewhere between the first and the second frame, you hit the G key on the keyboard. You press down on G. Processing says, time to wake up. Something has happened to the keyboard. At this moment, I will assign the value G to the global variable key, and I will call the routine called keytyped. Processing does this right away because at this moment, processing is not engaged in doing anything else. So now keytyped runs, and typically we keep keytyped very short. It just does something very quick. Maybe we set a global variable that a key went down, and we get out. Once keytyped is finished, processing goes back to sleep until the alarm clock rings again and it's time to call draw. Now suppose sometime later you press the S key. But where I've drawn it here now is you happened to type the S key during the time when processing is drawing a frame. So processing says, you know what, I'm not going to do anything about that for a moment. I'm going to finish drawing the frame and the thing gets drawn, and then it says, okay, time to go to work. The global variable key takes the value S, and I call keytyped. Keytyped runs and does whatever it needs to do, and then it's over. I mentioned that we try to keep keytyped very fast and very short. And the reason for that is we like having the frames coming up every 60th of a second. That's what gives us the illusion of motion and a sense of responsiveness. Suppose that keytyped did something very long. I don't know, it goes off to the web and it looks up a database and it takes a while. If keytyped takes a long time, Then the next time the alarm clock rings for us to draw a new frame, processing says, I can't do it, I'm busy. I'll just wait until key typed is done, and then I'll draw a draw. If key type takes a very long time, like a minute, then draw just doesn't get called for a minute and our program appears to have frozen. And that's not good. Now, if every once in a while draw gets delayed by just a tiny fraction of a second, that's fine, you'll never notice it. But you don't want draw to get delayed by a whole long time where the program's going to start looking like it's stuttering or freezing up. So we keep key typed very fast and very short, and everything works very nicely. And I'll show you what goes into a typical key typed, and you'll see, yes, it's very quick. One more thing we need to add is what happens when a key is released. So let's say that after you've pressed the G key, you then release the G key. Releasing the G key is an event that processing picks up. It says, oh my gosh, I've got to do something about it. I'm not currently calling draw, so I can respond to this right away. What does it do? It sets the global variable key to the letter G, because that's the key that just got released, and it calls the routine key released. And key released comes in, does its job. Again, we usually keep it very quick, and it's over. So this picture shows you the general flow. Draw gets called every time the alarm clock rings, unless something else is going on. And every time you press or release a key on the keyboard, the routine key typed or key released gets called as soon as it can, with the global variable key set to the letter that was just pressed or released. That's the general idea, so let's actually make a key typed routine. Every key typed routine begins the same way. Void key typed. Paren, space, open curly brace, and at the end, a close curly brace. This is just like draw or setup or any of the routines we've seen before in that it returns nothing. So it has a type of void and it has no arguments. So it has a pair of parentheses because it's a function, but there's nothing inside because nothing goes in. The way processing communicates with key typed is by setting the global variable key. So the first thing we'll do is we'll usually try to see which key got pressed. So let's write an if statement. So this if statement tests if the global variable key is equal to the character G, the lowercase g. If it's true, if the user just pressed G, then I'm going to do something very simple. I'm going to pretend that there's a global variable called G key pressed, and I'm going to set it to true. It's not the job of key typed to really do anything with the key that got pressed. Key typed is only there to kind of figure out which key went down and remember that information so that later on draw can do something with it. What if we'd like to check for another key, like maybe the S key? No problem. We'll just say, hey, if it's not the G key, else. If maybe it's the S key. If it is, we'll set some other global variable to be true. So in this way, we test for each possible value of key that we're interested in, and somehow we do something quick and easy to remember that that happened. Let's actually implement something useful in key typed. I'm going to pretend we have a side scroller game. This is an old school kind of video game where we have a character that's moving from left to right. We have a desert scene, so what is the most reasonable thing to put into a desert? A snowman. So the snowman's job is to get from left to right, and he's got to hop over the rock in between. How do we control the snowman? If you have 4 arrow keys, you can use those, but a lot of keyboards don't have arrow keys. And so early on, when people were first making these kinds of games, they said, we'll also use the W, A, S, and D keys. So if you want to move to the left, you press A. If you want to jump, you press W. If you want to crouch, you press S for down. And if you want to move to the right, you press D. So let's write a little key press routine that will let us control the snowman by pressing these various keys. We begin by creating the outer wrapper, void key typed, paren, space, open curly brace, close curly brace, and what goes inside? Well, we're going to test against the 4 keys that we're interested in, W, A, S, and D. So let's test for them. We have to take them in some order. I'll start with A. So if the key is A, then we'll do something. And for right now, I'm just going to have a comment. We know it means go left. If we're not going left, well, we'll test for the others. We'll test for D. We know that means go right. If the key was W, we know we want to jump, and if the key was S, we're going to crouch. This is a complete key-typed routine. Now, we just have comments for the actions, but we're testing for each of the keys, and if the key that was typed is not one of these, we just ignore it. Nothing happens. You can sit there and hit the P key as often as you want, and our program won't respond. It only cares about A, D, W, and S. And that's a very good start for key-typed. In part 2, we'll improve this and see how this routine can be used to control our snowman.